Hi everyone, I'm Rohan Ravindranath, the Principal Solutions Architect, and in this section, what I'll be talking about is how you prevent threats from spreading at a micro and macro level once you have your applications in the cloud. So this is going to be the second part of our segment today for hybrid multi-cloud. And in the first part, we looked at how you can basically get secure on-prem to cloud connectivity using a consistent programmable security model. So once again, to bring into context the periodic table, so you have a Ferrari of features that can be used, right? In this particular context, what I'm going to use is the ones in red, which are going to basically be part of the cloud microsegmentation stack. And with that, let's go straight into the demo, right? Now, what I have here is a kind of a lower level design into what you would see on any cloud, right? This happens to be on AWS. So what we saw in the previous section is how we can deploy our viewers instances with full zero-touch provisioning and make them be security gateways in the cloud. Now, let's take a look at a typical scenario that you have, right? You might have a three-tier app, maybe which has web, app, and DB, right? And let's say that you have different workloads or applications or containers in one particular subnet in one particular VPC, right? So we're now talking from the perspective of, it's not in two separate VPCs, which would be kind of be macro segmentation. We're looking at it, we're actually looking at it from a micro point of view. All right. So now typically right now, if you have a compromise of one particular workload or container, what's going to happen is that, it's going to be very easy for this compromise to actually go ahead from here and move on to this, hop onto this, because this now has kind of wholesale access into everything within that subnet. Now, there are a couple of ways in which you can address it, right? And one is using maybe an agent on every single workload. But that has problems with scale, and an agent can really look at things from a layer 3, layer 4 process perspective. You really can't do any kind of layer 7 deep packet inspection or really prevent yourself from, zero-day attacks. So where Versa is unique in this space also, right, is that it can programmatically talk to those resource managers on, Azure and AWS and GCP, and then decide on a per segment basis, the transactions which are happening between these different workloads, have it pulled and redirected towards Versa, and then scrubbed against our contextual policy based on the identity, group, application, posture, and time of day, and only then make the transaction go through or not go through. So what I'm going to do as part of the next part of the demo is that I'm going to show you, I'm going to have one workload over here, which I'm going to log into. And I'm going to simulate or actually show you through a live detonation how transactions between something which is on the exact same subnet within this VPC can be blocked. So let me log into my first server, and just to show you that what IP the server belongs to. If there are questions, please go ahead.
A question, yeah. Before you jump into the demo, can you elaborate how where the enforcement is happening when you're blocking something?
Sure. So what's happening is there are a couple of different things which actually happen under the hood. Okay, so one is our ability to talk programmatically to those resource managers. Two is a granular ability to do policy-based forwarding. So we can say that, for example, I want to scrub this segment based on whatever source or segment or tag or any other kind of identifier that I want for that segment, and then go ahead and make it get attracted towards the Versa instance, right? And now what will happen is that, we would override that specific route, the default system route, which is there on any of these clouds, and have that traffic attracted to Versa. Okay, so that's the first thing, right? Now, the next thing is, once it comes over here, the next aspect is looking at that full stack security policy, right? It's just basically two simple things, right? We've just extended what I showed you in the previous case for macro, but use that intelligent way of communicating with the resource managers to attract transactions between workloads on the same segment. And then once again here, you can use either a granular policy stack, you can override this and make it more specific, or you can just use something which is out of the box.
Yeah, thanks, but I did not get how you insert the Versa between the workloads within the same subnet.
Got it.
How you're exactly doing that. You're just programming the routing table within the host to do that.
Exactly.
But
We're programming, we're basically programming those tables. It could be based on, we really don't want to do it based on an IP segment, right? Again, because IP is really ephemeral in the cloud, right? So we could do it based on tags, right? So we can say, this particular tag, go ahead and attract the traffic towards Versa. On the back end, it essentially programs the stack of Azure or AWS or GCP to now redirect traffic to go to the Versa appliance. And that's where it's scrubbed against our policy and everything else, like we talked about previously.
Yeah, but
essentially, if you think about it, right?
Yes, it can be intercepted from the attackers. If for example, someone is controlling the virtual machine, then it means that they can manage the routing table pretty much on the host itself.
Okay, that's a very good question, right? So what if I go ahead and change this route to now point to something else? Instead of Versa, I go ahead on the operating system and I point it towards the internet, as an example, right? Now, the good thing is that on the cloud, right, because you never really have control of the infra, only the cloud service provider has control of that infra. The minute this packet exits this particular virtual NIC, it has to reference the route table to which this subnet belongs to. It really doesn't matter whether this says go out to the internet or go out to any or basically go out to anything else. The minute the packet exits the NIC, it's going to reference the route table. The route table was programmed by Versa, and the traffic is going to come towards the Versa appliance, irrespective of whether an attacker goes ahead and programs the OS to basically point to anywhere else. Now that is also a very good use case which you just brought up, because it makes it very powerful, right? An attacker could go ahead and do whatever he wants on an OS level. It really doesn't matter. The traffic is going to pass through the appliance based on the way in which we have programmed these different constructs in the cloud.
Okay.
Right. So, right.
Can I jump in with a question here, Rohan?
Sure.
There's competing products in this industry. You specifically called out, agent-based solutions have scaling problems when they attempt to do this. Can you, I also see a scaling problem by using your system to modify host routing tables. Can you talk about why you think that that's less of a scaling issue than using an agent-based solution?
Absolutely, right. That's actually a very good question. So the thing is, right, we are not modifying the host routing table. So what is there on the operating system remains unchanged. What we are modifying is the infra routing table in the cloud, right? But essentially, when the packet leaves, it has to reference this particular routing object, right? Now, let's say that this happens to be a /24 subnet. We could have 254 hosts there. How many iterations did I make to program it? Just one, right? One for all these 254. If it was a /16, those millions of hosts within it, I would just need one single routing update over there. All of it would be attracted to Versa. So now you're not looking at it at, I had to make, 10,000 API calls. It was just one API call in order to do that. So that's how it's a much more scalable solution than using an agent. Apart from the fact that an agent, while useful in certain cases for doing process level based segmentation, can't really do, a full DPI stack. They just don't have the resources in order to do that in the first place. So that's where they also become ineffective.
Okay, no, cool. I understood it differently when it was first explained. Thanks for clarifying how that works.
Sure. Right. So let me log into the first VM over here, right? And I just want to show you, what this basically contains. So, so the first one is 10.25.4.4. Okay. Now I'm going to look at the ARP cache, and we see that we have a couple of hosts which are there in the same segment, right? You can see the MAC addresses learned dynamically, and they're 4.5 and 4.6, right? So what I'm going to do is to basically pull a live transaction of data between these two hosts over here. And remember, right, if I bring up a new host .7, .8, .9, it doesn't matter, right? Because all of them are going to follow the exact logic which I've programmed now using our Versa interaction.
Excuse me, Rohan, can you show the route table, please?
Sure. The route table here?
No, in the VM.
Oh, we would have to log. Oh, here? Okay, sure. Oh, route. Okay.
IP space route.
Yeah.
That works too. All right, thank you.
Right. So now let's actually log into, and I'll show you what I'm going to basically make a transaction with, right? So I'm going to go to repo.acme.com, right? So I see that it's 10.25.4.6, which was another host in the same segment, right? Now that is this particular guy, okay, repo.acme.com. Now let's say that I'm going to download some files. So the first thing is that I download this. This seems to be a legitimate transaction. It has gone through. I see a nice, beautiful picture of Switzerland. And now let's say that, there was a file which said important update.zip, right? So I go ahead and click on it. You can see that something got reset over here. And if I go ahead and click on this readme.txt, I see that the transaction itself was canceled, right? Now we'll dive into the analytics as to why exactly that happened. But before that, what I showed you was could be considered to be a simplistic, file transaction between two servers on the same segment. What if it's actually more complicated? What if it is ransomware movement between these two segments? Or what if it's some other lateral movement-based attack between these two segments? So let me show you how we can actually prevent that also from basically taking place, okay? So I'm going to come back into our hammer, and I'm going to now show you what we could do with respect to, let's first go ahead and trigger some malware, right, between this. And I will just go ahead and clear these sessions, right? And I'm going to save and run this, okay? So I've started to trigger some malware in between, those hosts which are talking to each other, okay? And let's take a look at what's going to happen, okay? So some of it is getting blocked, but even before we get to what it is and what exactly is happening, let me show you what I'm actually pushing. Right. So if I come back here and if you take a look at the live malware that I'm detonating, I've actually picked something right from August 2021. And this might be familiar. It's the Black Matter ransomware as a service, right? And this follows a very similar pattern to REvil and DarkSide. And just to give you context, the ransoms of Black Matter have been in the tune of $15-20 million, right? That's just to give you a little bit of financial context into this ransomware as a service. What I'm also going to do, just in the interest of time, is that I'll also fire another lateral movement attack, right? Which is a little different from Black Matter, and I'll talk about what exactly happens as part of those transactions and what we're exactly blocking. So let me come back to let's come back to the test in the first place, and let's see what all was blocked as a result of the transaction. But even before that, let's go ahead and fire some lateral movement based attacks. Okay, so I'm going to switch all of these on, and I'll talk about in detail what we are doing as part of this transaction. Okay. So first of all, before that, let's go ahead and in live configure a lateral movement protection from Versa, right? So I'm going to go ahead and jump into this, and let's say that, I just go ahead and I can just duplicate this and put it on the top. And what I'm going to say is I want to give lateral movement protection, right? So once again, I've not selected any sources, any destinations. So I'm saying, in all directions, irrespective of where it's coming from, I want to go ahead and apply a security profile. And in this case, all I'm going to do is to go ahead and select that I want this to protect me from lateral movement. Right. So I'm going to say, protect me from lateral movement. And I also not only want to detect, I want to protect. So I'm going to say, if you detect lateral movement, go ahead and reject that transaction. Right. So I'm going to say, okay. And once this comes through, in the meantime, let me just go ahead and fire in all of the different services that I'm going to be using. And I do have it logged as well. Perfect. Okay. So now what I'm going to do is that we'll fire in our lateral movement attacks, and I'll talk about what these attacks are basically going to do, right? So let me save and run this. And let's see what's happening over here. Let's make sure it is started. Okay, so it started. It looks good. All right. Okay, let's jump back in and let's talk about in a little bit what exactly happened, right? So as part of actually moving these lateral movements over here, right? A couple of things actually happen. And you know what? While I'm talking through it, let's actually keep looking at the analytics screen, and we could also look at it from our logs from the device as well. And we can actually see all the lateral movement based attacks which were basically rejected. But let's look at it from the analytics, right? So what's actually happening in both the Black Matter ransomware as a service as well as lateral movement is a couple of different things. One is that the attacker is going to use some sort of embedded credentials, right? And typically they do some sort of program in order to latch on to the LSAS service of Windows, kind of get a dump of the different users and hashes, And this could also be simulated using a program like Mimikatz as an example, which can latch onto the LSAS. And using those embedded users and passwords over an SMB channel, discover all the other hosts in the same domain. And then after that, go ahead and use something like MSRPC to find out, what are the share drives available within these hosts, right? And typically that targets things like, C dollar, admin dollar, sys volume, and stuff like that. And once it enumerates all of these, to go ahead and then do a remote procedure call, go ahead, schedule a task, and basically go ahead and encrypt these volumes, right? So that's how it basically does a compromise of different NTLM hashes, uses that over an SMB channel, goes ahead and does privilege escalation, and then goes ahead and encrypts it, right? So there are many, many different fundamental blocks, but different transactions which happen, and they don't happen at the same time. So that's why even in the list which I had shown you, which I had fired, right, you saw there were different levels of attacks which are made. Everything is doing a different process in that entire set of transactions. Now, let's actually take a look, right? Let's actually take a look and see whether we actually caught something, right? So if I come back here under security, and if you go to threats, so now if you go to something like vulnerabilities, we can see that we have lateral movement. And if I click on lateral movement, we can see exactly what job it found as lateral movement between those different client and server communications, and what it actually stopped, right? So you remember I told you about the fact that it's trying to realize what are the shared volumes available using those embedded credentials, and try to basically send a payload to C dollar, right? Over something like SMB. And that is what we are actually catching in all of these different transactions. And of course, we could look at a PCAP and we can get really, really granular, but just in the interest of time, I just wanted to show you live from the analytics what you can see in terms of all those different transactions between this, both in a ransomware as well as in a lateral movement scenario of what was detected and blocked from our solution.